My name is John Siebenmorgen,
And my name is Aaron.
and this is our program on Rust. So, Rust is a modern language which was written by Graydon Hoare of Mozilla. It all started when he got stuck at the bottom of a staircase waiting for an elevator which had broken because the programming which caused it to function had malfunctioned.
And when he was thinking about this situation, he realized that a lot of the elevators at the time were ran with C++, and he thought to himself, well, C++ isn't really too reliable because, well, there are many different issues that can come across in C++, like, well, there's situations where you can go out of range of an array and it won't say anything about it, and you can just manipulate that data or anything like that. And so it could cause many issues in elevators. And so he decided that he would think about a way to create a language that would take into consideration the speed of C++, but also incorporating many safety features to it and calling it Rust. These safety features, well, there's many different kinds of things that we'll explain in the future of this presentation, but all you need to know is that he wanted to create Rust with the sole purpose of efficiency and data safety.
And Rust is used by many corporations today, including, as you see, Dropbox, Discord, Cloudflare, and Amazon Web Services. Discord, I know concretely, had used C++ and some other languages for their messaging app, and they found that it was gravely inefficient and it wasn't working as it should. So they had a new group of programmers come in and revamp the whole system in Rust and found it to be extremely fast, very efficient, and I think they even cut some of their servers almost in half.
And so, after all of this has been said, showing a basic program that's like Hello World will help understand how the structure is for Rust. And so, this is our Hello World program, and we generated it, and it's a similar style to C, which is basically creating a function, which that's what the fn means right here. And then you declare a main, which is similar to C, where you have to do a function main and you put anything that you want ran into that main function. And the print method uses the stdout method similar to C. And the way we have it right here is that you do println exclamation point, which is a sort of macro, and then you put whatever string that you want to print inside it. And you can also do semicolon. Uh, in this situation, the println exclamation point will mean that it prints the string first and then attaches a new line to it. So it'll print hello world and then new line. But it also offers things like print exclamation point, which will print the string, but nothing else happens. It doesn't print a new line. So if you do another print statement, it'll basically print right after it. And you can also do things like if you want to declare a variable right here, you can. So what you can do is have a bracket right here and then have a closing bracket. And so after that's done, it won't do anything unless you do another thing with a comma after the closing quotation marks and provide a variable name. So if I have var1 and let's say let var1 equal something like test, then it'll properly print the statement to be output equals hello world test. And I'm sure that there are other languages that incorporate this, but this is just one of the interesting features that Rust provides. And so now, to be able to learn Rust, there are many different sources to uh, help, but one of the things that is provided by Rust is the Rustling documentation, which was created by the person that created the language and also his team. So if we go over to something like the Rustling documentation and view it, we'll okay, so here's the Rust language documentation, and it starts off with the Rust programming language, which is just a brief introduction to it. And it provides an index of different things that you can click on, and it'll go in order. It's it's kind of structured in a sort of hack job way, I guess, because the person that created it, which was the person that created the language, designed it where it'll start with basic programming concepts, which is not really a friendly way to introduce the person that's beginning a programming language because, well, if they don't know anything about these things, it's just kind of there and it spews a ton of information and explains things that are not even common in some languages that you might see, like shadowing. And then it goes into things like it jumps straight into pattern matching and enums, and then right after that, it goes into managing growing projects with packages, crates, and modules, which gets into a bunch of mess because you're still messing with different things like package management, installing different packages, and just pushing them and all kinds of different things. And one of the things that I will say is good about this documentation is that in these text boxes, it'll allow you to run the program and it'll display different things. And so if we go back to our slides and talk about the different resources. Another resource is YouTube. It's not really that good of a way to learn the language because when I was looking through all the YouTube resources, there were not many different things covering it. It's just kind of like it's not really friendly because the videos are like 12-hour long videos and trying to make you learn it in all those 12 hours. And if you're anything like me, it's kind of like with the way I learn, it's not really effective because I try to do it all in one straight shot, and that's not really a good way to learn a language. And who's to say that these people are even good at being structured in the way they teach? It may not be friendly to a person that is learning a new language because it might start at something like object-oriented programming or something like that when you haven't even learned the basic structure of variables or how a main function is in the language or anything like that. And also going into the compiler, there's the main compiler is called Rust C, which compiles the program but does not run it. So what it does is after calling the Rust C command on a file path, it will refresh that uh, program it in a way to make it where the most recent run will update and run that most recent compile thing. And if you type new information without compiling that program, it will only run that previous compile and not run any of the new things that you've typed in that program. It's not really a recommended thing to use Rust C to run this program because, well, it's just a raw compiler for the Rust language. And so there's a better way to do it. And that's through Cargo, which is a package manager. And it has many different kinds of commands and lets you do things like cargo run, which will run the file path and automatically compiles it while you run it. And it also allows for creating libraries, pushing libraries, and installing them. This includes things like if you want to install different regular expressions. So paradigms involve different kinds of things like functional programming and object-oriented programming. These things are further explained in different sections, but Rust just kind of implements many different kinds of paradigms from different programming languages. So the object-oriented programming in Rust is not really too defined. It's kind of similar to C++, where it's just kind of, it allows you to implement object-oriented programming, but it's not really primarily focused on it. And so it does, its structure is not really similar to other languages like C++. Instead, it will have a struct which you define as something like struct name, and you list all the variables within it, and that's all it does. The struct name only stores variables, and it doesn't provide any functionality by itself, and that's where the implementation section comes in, and you define it as impl. And so you do impl, and you do the same name as the class that you're wanting to provide functionality to, and you just type the functions in it. And it just allows you to define different methods that you want to interact with these variables, and it, as a whole, this is defined as an object. So before we go into the actual programming part of this language, it's important to understand the exception handling that is provided by Rust, because Rust doesn't really provide specifically exception handling. It has different methods to catch these errors, though. So one of the things that is required by all methods in Rust is to expect a method error. And so that would be done through something like dot expect, and then just have a message that will signify where the error is and why it occurred. And I guess this is really useful for when you want to kind of debug your code, because it allows for you to easily find where that error was, and it's a custom message, so it'll be self-explanatory. And there are two different types of errors that can occur, and different ways you can handle them. So a recoverable error is something that is not really a detrimental thing to the program. Like if you want to try to read from a file, but that file does not exist, it doesn't really cause too big of an issue if you don't do anything with that file itself. Instead, you're just printing it out. And so you wouldn't want to end the program, so you would just use the result, and you would go to this would allow for things like testing different occurrences through the matching switch, which match is just a fancy way of saying switch statement in Rust. And this allows for testing different kinds of errors that can occur. So if the error that occurred was file not read or something like that, then you could just say, print out a message that says that this might be an issue. But if you're looking for that issue itself, then you can call the panic method, which stops the program, which is explained right here, which is unrecoverable error. And so the panic exclamation point is a macro that will just say that the program should not run any longer, and it will cancel the program on the spot. So this is a program that we generated through ChatGPT, and it basically shows different processes that explain the data safety that Rust provides. And here's an ownership example where a variable is declared S1, and that just means string, and it creates a string called hello, and you define a string called S2 and you set it equal to S1. That will mean that S1 is no longer valid. It just completely transfers that information to S2, and S1 gets erased from memory. And so when you try to print out S1, it'll throw an error because it doesn't exist. So as shown before, if you do print ln S2, then it'll show hello in that specific statement. So here's a borrowing example where it's an immutable borrow, which let S3 equal world, and you do let len equal calculate length, and then you use a temporary string, which is just getting the address of S3, and it's only a borrowed method, so you can't really change it. It's just getting a reference to it. And so if you print S3 in length, it'll print those associated things, but not alter the data. So here's a mutable borrowing example where you define a S4 string which is mutable, and the mute keyword means that it's able to mutatable. And so if you do change string and set it equal to the S4 address, then you are able to change S4 through the reference. And S4 you can change, and it explains that. Another issue comes up with this section where if you define a variable that is immutable and a variable that is mutable, then if you try to set a mutable variable to an immutable variable or a reverse, then it'll throw an error because the compiler will not allow you to try and mutate an immutable value. And you can never change the state of a variable throughout the whole program because it's a statically ran program. So given the complexity of this language and how you have to test for a lot of errors, and given that you have to define a new string and all sorts of things like defining U32 to explain that this variable is an unsigned integer of 32 bits and all sorts of different kinds of things like this, it's not really easy to read because it's just a bunch of different characters that are kind of hard to read. The way to define things like variables, like using the keyword let, is not really understandable because while yes, you are letting a variable equal something, it's not, if you're looking at it from the perspective of someone who hasn't looked at a language at all, just saying let doesn't mean anything to them. And also, since you have to expect errors every single time you do something like reading a person's input, that can also pose an issue with writability because there's so many different issues that you can run into. Like, if you don't declare a variable as mutable when you're getting a user input, it could throw an error. And there's just so many different lengthy commands to do one simple task.
In regards to how the programs are compiled and when you're actually programming in Rust, some of the developers mentioned that they purposely overbuilt the compiler and the errors that they throw after the program crashes. And when it gives you the error message, they're actually extremely helpful in pointing out exactly where the error occurred and sometimes even giving the proper fix at the same time. So that was something that both users and also those that designed it had in mind, was a user-friendly aspect because it is obviously difficult language to program in. They tried to beef up that particular section. Another aspect that one of the developers mentioned was in other languages like C++, it seems like the compiler yells at you as soon as you make any slight tiny mistake, and the actual errors that they throw are extremely vague, and it could be 100 different things in C++ and Java. So this next part, I'm just going to go over some of the basic flow controls for Rust. As you can see, there's a lot of similarities between C++ and how the language is written. Obviously, there's differences like the let n equal 5, but the actual if-else-if chains here, they're all pretty much the same. And if you go to Rust by example, or you search that online, you can get these examples here. And you can actually run these right here, as we saw previously, and it'll give you the solution. And what I found really helpful is you can actually go in here and you can edit and change things, which makes it easier if you are trying to learn these languages and you want to do some practice here. And then the next section is loops. And again, very similar to C++, although in this case, they have a loop, which is an infinite loop by design, as opposed to something like in C++ where they have loops, which basically you have a while loop, which has a condition. And it's also worth mentioning to point out that basically you have to either use a continue or a break statement to get out of this particular loop right here. Additionally, Rust actually does not have a do-while loop, so a loop which iterates one time before it breaks out to test a condition. They thought that would be redundant, and to have something that you can program so simply as just simply inserting an if statement to have it break from the loop. So here in this example, you can see returning from loops. Essentially what they're doing here is that you have a variable for the counter, and the loop will continue to iterate through until it reaches the if statement there. And it'll hit the break counter and then multiply it by 2, giving us a result of 20. And at the bottom you can see it'll be printed out. And we can actually run it to where it should just equal 20. And here for the print line, you see that you have to include this statement here. Otherwise, if you don't, then it will probably not be very happy with you. Just to demonstrate, and then you can see also what the compiler looks like when you make a mistake. So it'll show you exactly where your error is, and then it'll even give you a suggestion of what you need to put in order to make it run again. The next control structure here, or flow control, is the for and range. Basically, it's a for loop, and the text simply, it's very comparable to something like Python, not anything like C++ in this case, where we have the for in 1 through 101, and it's exclusive, so it will stop at 100 instead of going all the way to 101. There is a way to make it so it's inclusive, which I think is down here. If you put 1 and then ... equal to 100, so it'll be inclusive of the final number that you put in there. And obviously, if I run this program, it'll be extremely long because it's going to iterate every time a value is divisible by 15, or a multiple of 15, then it'll spit out fizz buzz, and then if it's a multiple of 3, then it'll do fizz, and a multiple of 5, it'll shoot out buzz. I'll do it, but again, that'll be very long. So, but just to illustrate what exactly it's doing in this program. And again, you can always go to this website and you can look at it and again see how everything is running in each of these programs.
On to our next section, which is our individual opinions on the language. I actually really like the way this language does everything, as its structure is well defined. The language does not allow for mistakes to easily happen, since most of us have tampered with C++. I'm sure most of us have come across errors like reading an out-of-range address of an array. Rust does not allow for this to take place in the first place. On top of this, the amount of help that the compiler provides is really great. It helps learn the language quicker overall. I really like this programming language simply for the fact that its data safety measures are very dependable.
For my opinion on the language, I really liked it overall. I didn't get a chance to delve into it too deeply, but just from what I read on forums and people mentioning different different functions and, for example, the compiler and how helpful it is in telling you what the errors are, that really seems like it's a good feature to have and can make you a lot more productive in programming in this language. Additionally, they have a sort of, I guess, ethic or like a type of model that they try to preach, essentially that there's no such thing as a dumb question. So even if you don't understand something, they encourage their users to reach out and try and find a solution to the problem. So I really liked that sort of attitude that they have towards programming. And with that, we conclude our presentation. Thank you all very much.